Now here we have an example where we need to use logs to solve a problem with a GP, or a geometric series. Sales of a soft drink company are declining by 6% each year. Now straight away, as soon as I think of 6% loss each year, I realise that what I'm going to have each year is going to be 94% of what I had the year before. So that's important. We're going down by 6%, we're keeping 94% of what we had. We've got a clue here, 50,000 bottles were sold in 2016. When will sales first fall below 20,000 per year? I think that's probably meant to say. Okay, now, a helpful thing to do is just imagine what the sales might be each year. So if we've got 2016 here, and 2017, 2018, just write out a couple of things to spot a pattern. We sold 50,000 here. How are you going to find the sales for this year? Well, you're going to take 50,000 and you're going to multiply it by 0.94 or 94%, because that will give you a drop of 6%. Okay, then that is going to drop by 6%, which means in this next year we've got 50,000 times 0.94 times 0.94. So we can see a pattern here. We're going from our first term, A, of 50,000, and each term we're multiplying by something, and that's what a geometric series looks like, isn't it? It's to find each term you have to multiply by that common ratio, and in this case our common ratio is 0.94. Now, it would be possible to solve this using trial and error, just making up a bit of a chart and working out how many bottles were sold each year until you get to the answer. But that's a slow way of doing it, and we want to be able to work a little bit smarter than that. So, we've got everything that we need to come up with any term that we want of our geometric series. So we want to find the term that is less than 20,000. So first we need a formula for the nth term. Now, the generic version of it is this. You don't have to write this every time, but if you find you're forgetting it and needing to refer to your reference sheet, writing it every time would be a good way to get it back in your head. So on the next line, I can then say, well, I know what A is, it's 50,000, and I know what R is as well, it's 0.94, and I don't know N at this stage. So that gives me a good version for this question of my formula so that I can find any term. Now, I want to let the nth term be less than 20,000. So I need to solve and see what n would be when that's the case. Now, if this is going to be less than 20,000, this is going to be less than 20,000 as well. So my next line is going to be 50,000, 0.94, oops, to the power of n minus 1, has to be less than 20,000. And now I've got something to solve. Now we're trying to get 0.94 to the power of something by itself, so it makes sense as our next step to divide both sides by 50,000. So we have 0.94 to the power of n minus 1 is less than 20,000 divided by 50,000, which is 0.4. Alright, now from here there's a number of ways that you can go forward. One way that you can move ahead is you can say, let's take the log, I'll take the natural log this time, of both sides. Now, this method it's a good method, but it's a little bit fraught. You need to be careful not to make a mistake. At the next point here, you'll want to use the power law to bring the n minus 1 down the front, and that gives you this line. But on the next line, you need to be careful. And what you need to be careful of is that if you're taking the log of a number that's less than 1, and here we've got 0.94, this term here is actually negative. You can chuck this into your calculator now to see if you want to just check. So when we divide both sides to get the n minus 1 by itself, and that gives us over here 0.4 log of 0.4 over the natural log of 0.94, there's an easy way to make a mistake here. We've just divided by a negative, and that is going to flip the sign. On the next line, quite straightforward, we need to just take all of that and then add 1 to both sides, and we'll get our answer. Now, putting this into your calculator, it comes out with n is greater than, I think it's 15.8 or something like that, to 1 decimal place. Now, we can't have the 15.8th term, we need either the 15th term or the 16th term, and doing it this way, it's nice and easy to see that if n has to be a whole number and it has to be bigger than 15.8, then n must be 16. Now, we haven't been asked what n is, we've been asked when this is going to happen, so we need to give the name of the year. So just being really careful here not to mess up. Our first term, our second term, our third term, we have a bit of a pattern here. So if we want to find the 16th term, I can easily see that here, every time I add 1 to the term, I'm just going up 1 number. So clearly I need 13 more years after this, which is going to be 2031. And that's the answer that I've put in. Now, another way to solve it from here. You could use trial and error to just come up with 16. The other thing that you could do is instead of using this sign, all the way down here you could use equal signs. Now, one advantage of using the equal sign is that you're solving what n is, all the way down to here. But then here you'll need to think about which term you want. Now, the advantage of using the equal sign is that you won't mess up with trying to use the sign and be all clever and then getting it around the wrong way because you forgot that this was a negative here. The disadvantage of using the equal sign is you've got some thinking to do when you get down here to work out if we need the 15th term or the 16th term. The way I'd think that through is I'd say, well, after 15.8 years have passed, now we've just ducked below 20,000 bottles per year. But if we've got something that's falling all the time, then to actually go below that number, not just to reach it, but go below it, we need to go up to the next term. And so I think logic helps you a little bit to think that through. Some people find that step really easy and others find that step hard and much prefer to use the signs all the way down.